Good day, everyone, especially to you, Sir Abelia, and to our classmates. I am Engine Cadet Montaño Winrich Luis M., and together with my partner, Engine Cadet Junio Joshua C., we are from the Group 3, and we are here to report about our topic, which is the measurement of flow, its process control system, and the PID flow. And to start with our discussion for this topic, let us have my partner, Engine Cadet Junio, for the measurements of flow.
Thank you, Cadet Montaño. To start our presentation, let us first know what is measurement of flow. Flow measurement is the process of quantifying the bulk movement of fluids. There are various devices called flowmeters that can be used to measure flow in different ways. So when we say bulk is kanang dinagko ba siya nga para sa kanang mga oil tanker ana. Ang mo flow sa tubig niya is dinaghan mo na i-measure. Next is some common types of flowmeters with industrial applications include obstruction type, inferential turbine type, electromagnetic flowmeter, positive displacement flowmeters, fluid dynamic vortex shading, anemometer, ultrasonic flowmeter, mass flowmeter, or Coriolis force. First is obstruction type. These flowmeters use a blockage or narrowing in the flow path to measure flow. It checks the pressure difference or the position of the moving parts like a float to determine the flow. So makita ninyo sa picture is nasa sa ibabaw gubos nasa murag obstruction niya nasa nagbabag ara di bali masangit ang fluid nara sa nasa sensor nga mao ra say mo sa unsa ka kusgon ang flow sa fluid. Next is inferential turbine type. These meters use a spinning turbine or propeller in the fluid to figure out flow rate. The faster it spins, the higher the flow. So sa kana nga sa picture guys, makita na ninyo ang sa sud ana is naa siya murag na siya rotor magtuyok na siya ug unsa kapaspas ang iyang tuyok mausad kapaspas ang iyang flow sa fluid. Next is electromagnetic flowmeter. It uses magnets and the flow of conductive fluid to measure flow. It detects the fluid voltage created as the fluid moves through a magnetic field. So kaning electromagnetic flowmeter is nasa magnetic field sa naglibot sa kanang tube or pipe mo create na siya og voltage in flow sa kanang fluid maura sad na mo measure sa unsa ka kusgon ang iyang flow. Next is positive displacement flowmeters. These meters fill up and count small volumes of fluid to calculate flow rate. It's like counting how many buckets get filled. So makita niyo sa picture is mura siya gear pump di bali ana nga na magtuyok ng duha samtang magflow sad ang fluid. Next is fluid dynamic vortex shading. These meters use the swirling patterns vortices formed by obstructions in the flow to estimate flow rate. Maura sa ni sa obstruction type ang nga naa sa tunga kanilang nasa sa tunga ang iyang obstruction ara maigo di bali ang fluid masangit ang fluid unya sa unahan na sa mo sense sa murag ma pressure niya adto ra siya mo measure o unsa ka kusgon ang flow sa fluid. Next is anemometer. Anemometers measure airspeed. They are like wind speed meters and can also measure gas flow. Kini siya is magamit ni siya sa mga gas or vapors ang karga sa ships ana. Next is ultrasonic flowmeter. This type sends sound waves through the fluid to measure how fast it's moving. It's similar to how bats use echolocation. So makita niyo sa picture guys mo na yung purmas sa ultrasonic flowmeter. So musend na daw siya sound wave sa nagflow nga fluid aron mao sa mo toy mo measure sa unsa ka kusgon ang iyang flow. Lastly is mass flow meter or Coriolis force. This meter focus on measuring the weight of the fluid. They use the Coriolis force, which is twisting motion, to figure out mass flow. So kanang sa ubos guys murag na siya na curve na siya sa ilawom sa soda na siya duha ka tube unya adto sad mo agi nasa mo agi ngadto nga fluid. So nya kadto nga tube sa ilawom ay murag hose to di bale maglihok daw to or mo twist samtang magflow ang kanang fluid o kung sa ano ka kusog daw ang flow sa fluid kusog daw sa to mo twist ang kwan or mulihok ang katong duha ka hose or tube sa ilawom. Next is flow measurement methods other than positive displacement flowmeters rely on forces produced by the flowing stream as it overcomes unknown constriction and directly calculate flow. Flow may also be measured by measuring the velocity of fluid over a known area. For every large flows, tracer methods may be used to deduce the flow rate from the change in concentration of a dye or radioisotope. Measurement of flow. In water resources, flow is often measured in units of cubic per second, cubic meters per second, gallons per minute, or other various units. The accuracy of flow measurement is crucial in many industries, including chemical wastewater treatment, pulp and water, oil and gas, and others. The continuity equation is used to present the flow rate in a pipe under steady state conditions, where the water that flows into one end of the pipe must flow out of the other end. So, ang gamiton sa mga units ini ma-measure na ang flow rate niya is kanang mao ning mga cubic feet per second, siguro kadungog naman taan ni nga mga term is kanang cubic meters per second, cubic feet, gallon per minute ana. That is all for my part, and now let's have again Engine Cadet Montaño to discuss about the process control system of the flow measurement and the PID flow.
Thank you, Cadet O'Neill. And again, everyone, good day. I am here now to discuss to you the process control systems for flow. So, what is a process control systems for flow? From the word itself, control systems. It consists of instruments and devices that are used to monitor and control the rate of fluid flow in industrial processes like machineries and many more. So, what is the process of control systems for flow? So, typically in the measurement flow, these systems use flow meters to sense the amount of flow passing through a particular pipe, then send this information to a process controller, which then applies a process logic and controls the flow rate. So in short guys, it is a closed loop system which monitors and automatically maintain a variable at a desired point. So as discussed sa mga niaging simana, closed loop system consists of input, uh, feedback, then adjustment, then output. So more na siya like katong scenario naghatag ni Sir Galit like the three engineers, which is the second engineer acts as the flow meters or the sensor. Then iya ihatag ang information kang chief engineer if sakto ba ang flow rate. Then si chief engineer ang process controller which will decide na iya ba subuon si third engineer na iyang padak-an ang valve or i-close niya ang valve gamay to adjust the exact amount of flow rate in a particular pipe. Then we have here the importance of flow measurement and process control cannot be overstated. So means dili siya angay exaggerate or palapinan since it is a vital function used to monitor and control the rate of liquid flow in applications. So we also have here the accuracy of flow measurement is crucial in many industries. Like sa atuang mga marino, we have the auxiliary machineries like the ballasting, the tanky, water treatment plant, oily water separator. Some of it also uses measurement of flow. And to achieve a solution with automated controller, the delivery quantity, a flow computer is used to monitor the amount of liquid transferred and controls the flow rate. So again, control systems consist gina siya of computer which are the devices and the instruments na to control the flow rate in advancing field. So kadalasan siya i-use is sa mga bulk fluid movement which can be measured in various ways. So as discussed kaniha ni Cadet Junio, so bulk fluid movement. So it is used in bulk fluid movement meaning dinagko o dinaghan. Okay, so next we have the diagram of process control systems for flow. So here you can see a liquid flowing in the tank. Then there is the level transmitter which acts as the flow meter. It senses the amount of flow passing through the tank, then sends the information to the level controller which acts as the process controller, then sends the feedback to the control valve which is adjusts the flow rate in the desired variable, then going to the output which is this liquid side. So lastly, we have here the PID flow. So PID stands for Proportional Integral Derivative Controller. So it is a feedback control algorithm commonly used in engineering and industrial applications. So it is designed to regulate a process variable such as temperature or pressure. So regulate means to control or maintain the rate of flow in the process so that it operates properly. So again, it is designed to regulate a process variable such as temperature or pressure by adjusting the control input based on the error between the desired set point and the measured value. So as I mentioned earlier, the PID stands for proportional, integral, and derivative. So the PID controller calculates the control output as the sum of three terms. So those three are so-called terms and has meanings to control their own way or to have their own way of controlling the system. So each term contributes to the control action in a different way. So these three is a terms and has meanings that have their own ways of controlling the system. So first we have here the proportional term. So proportional means corresponding in size or amount to something else. So, proportional meaning aligned or pareho. So, proportional term adjusts the control output in proportion to the difference between the set point and measured value. So, as I mentioned kaniya, proportional means the same. So, if ever naanay gamay nga dili pareha or gamay nga difference, it provides automatically an immediate response to the error. So that's how the proportional term works. But sometimes it may result in a steady state error. So next we have the integral term, which accumulates the error over time and adjusts the control output accordingly. So integral, it means necessary to make a whole complete. So meaning sa usa ka tuyukan, nakaset na siya sa usa ka tuyukan, kailangan kumpleto na siya. So, ibutang ta lang sa usa ka tuyukan sa oval, kailangan maabot siya in 12 seconds. So, if ever nanay difference nga usa lang ka segundo or dili complete ang iyang tuyok sa naabot na ang 12 seconds, then ara na mo show ang integral term or ara na mo operate ang integral term. So, it accumulates the error over time and adjusts the control output accordingly. So, PID or the integral term also helps to eliminate steady state errors and provides a stronger response as the error persists. So, lastly, we have the derivative term, which predicts the future trend of the error based on its rate of change. So, ang iyang pamaagi, it anticipates the system. So, the rate of change of a function with respect to a variable. So that's the PID controller diagram. Here we have the input, then the flow control valve, then the output of the control valve, feedback, then the output of the feedback. So flow measurements and control are indispensable components of various industries. It ensures precision, efficiency, and safety in industrial process. So again, process control systems, not just for measurement of flow, it ensures precision, efficiency, and safety in industrial processes. The array of flow meter types and the application of PID controllers is exemplify the continuous advancements in technology and fluid dynamics. So the PID controllers are now plays a critical role in fluid dynamics. And as industries continue to evolve and demands for accuracy grow, the synergy between flow measurement techniques and control algorithms remain pivotal for achieving optimal results in fluid management industrial operations. That's all, sir, and thank you very much.